Greetings, Panthers. It's Dr. Augustine. How are you doing today? We are going to take a look at prefix multipliers, using these prefixes to express, again, large and small numbers. The topic we're dealing with right now in the chapter is large and small numbers. We already said that chemistry involves large numbers. How many atoms are there in a macroscopic object is going to be a large number. And what's the mass of a atom is going to be a really small number. So there's a system of these prefixes that can be used to help make the numbers a little bit more reasonable in size. This covers chapter 1.6 intro. And rather than using chemistry examples, once again, we will start with our crazy Zimbabwean dollars and these big denominations. So just to recap from the first video in this series, this $1,000 bill, we can rewrite using scientific notation as 1.0 times 10 to the 3, and we'll call it Zim dollars. That'll be my units. The $50 million note was 5.0 times 10 to the 7 Zim dollars. The $20 billion note was 2.0 times 10 to the 10, and we'll call it ZD. How's that for Zimbabwe dollars? And the $100 trillion was 1.0 times 10 to the 14 Zimbabwe dollars. Okay, so those are my notes from before, and we've used scientific notation to help us make that crazy number a little more reasonable, 2.0 times 10 to the 10. We have not talked about the significant figures yet. That'll be in the next video, but this is a way of expressing these big crazy numbers in a little bit more manageable format. But sometimes you don't like to use the 10 to the 14. I mean, that's a little crazy also, or 10 to the 7. So sometimes we want to use just a word that means 10 to the 7. And that's where this table comes in at the bottom. Okay, and this is a table of prefixes that we can use for large numbers. So above this red line, these are large numbers greater than 1. And below the red line, these are small numbers less than 1. Okay, and so, for example, kilo means 1,000 of something. So if you have a kilometer, that's 1,000 meters. If you have a kilo dollar, that would be $1,000. So we can use this multiplier here to convert from whatever this base unit is, in this case Zimbabwe dollars, into something that has a name in front of it or a symbol which means the same thing. All right, I'm going to scoot this down just a little bit so this is all on the same screen. And so let me show you how the conversion factor works. So let's take this first one here, this 1,000 Zim dollars, and I want to use one of these prefixes, but I'm going to pick the one that's closest to the multiplier. Obviously, in this case, 1,000 is going to be closest to the multiplier. So I would say 1.0 times 10 to the 3 Zim dollars times 1 kilo Zim dollar for every $1,000. Zim dollars is my base unit. So Zim dollar is going to cancel Zim dollar, and this is going to give me 1.0 kilo Zim dollar. Okay? Careful to know what we did here. We've set up a calculation. Remember, the conversion factor is always the second thing. I'm going to cancel out units. Zim dollars is canceling Zim dollars. And this is a super common mistake, so I want to highlight this now. This conversion factor and these tables, this is a super common mistake, and that is the base unit always goes on the bottom, and that's what this 1,000 is right here. Okay, so it's always one of whatever the thing is you're converting to on top, and then whatever this multiplier is goes on the bottom, 1,000, or we could put 10 to the 3. And the 10 to the 3 or the 10 to the 6 or 10 to the 9 gets applied to the base unit, which is Zim dollars. Again, this is a super common mistake. Students make this all the time. I just want to beat this into your head right now. I mean, get this into your head right now. This thing here applies to the base unit. Okay, that's how you read, that's how you interpret this table, is this 10 to the 3, 10 to the 6, 10 to the 9, etc. That gets applied always to whatever the base unit is. All right, so let's take a look at this next one, and let's take a look at the $50 million note. All right, so again, this is 10 to the 7, and so we would want to come down here and say, which one's close to 10 to the 7? Well, 10 to the 6, that's pretty close to 10 to the 7. So we are going to convert that into mega. So 5.0 times 10 to the 7 Zim dollars times 1 mega Zim dollar. Why am I using a capital? Well, that's what the symbol is. Capital M means mega. Okay, little m means milli. So we want to use a capital M here. So 1 mega Zim dollar for every 10 to the 6. So it's every 1 times 10 to the 6th Zim dollars. Zim dollar is going to cancel Zim dollar. And when we do this calculation, we will end up with 50 mega Zim dollars. So you see how we can get rid of this 10 to the 7 by just using this term mega. That means million. That means 10 to the 6. So if I have 50 mega Zim dollars, that means I have 50 million Zim dollars. All right, likewise, we'll do the $100 trillion just because that one's kind of fun to do. All right, so 1 times 10 to the 14 Zim dollars times, now we want to pick one that's close, 10 to the 14, so it could be this one or this one. I'll show you how to do both of them. We'll do tera first. So if you want to stop the video and do it yourself, you can sort of make sure you're on the right track here, but we'll do tera first. Think about what the conversion factor needs to be. All right, so it's going to be 1 tera Zim dollar for every 10 to the 12 Zim dollars. Zim dollar cancels Zim dollar, and this is going to equal to 100 tera Zim dollars. Now you might have picked the other one. You might have said, well, 10 to the 15 is actually closer than 10 to 10 to the 14 than 10 to the 12, so I want to use this one. I'm going to use peta here. Okay, so let's see what that conversion looks like. 1.0 times 10 to the 14 Zim dollars times 1 peta Zim dollar for every 10 to the 15 Zim dollars. Again, that cancels that. So now we're going to end up with 0.1 peta Zim dollars. Both of these are correct. Either one of these both express the exact same thing, and one is not preferred over the other. There's not a rule that says you can't have a decimal place. Actually, if I want to be consistent with sig figs, if you're watching this video after you watch the sig fig rule, we should write this 0.10. Okay? So every one of these express the same, these two express the exact same number, and there's one not preferred one over the other. Usually the problem will give you some indication, you know, how many tera Zim dollars are there, and then you would want to use this calculation right here. Okay, so moving away from these crazy currencies, let's deal with something a little bit more realistic. So I'm just going to make up a problem here. Let's say we have a question like, how many nanometers are in 372.5 meters? Okay, that's a more realistic calculation for the type of thing you might have to do in a chemistry or physics class or something. All right, so what we would do is we would take a look at this table and we'd say nano 0.000000001 10 to the minus 9. So nano is a really small number. That's a way of expressing something that's really small. 300 meters. So if you think about how big a meter is about the length of your arm. So this is going to be a pretty big thing, right? So a football field is about 100 yards long. A meter and a yard are almost the same. So this is about 3 times the length of a football field. So we expect there to be a lot of nanometers in in 372 meters. So how do we set this up? All right, so we say, so I'm going to write like nanometers. That's what I'm looking for. So it's going to equal to 372.5 meters times, all right, now we go to the table and we say, okay, nano is 10 to the minus 9, or you can put all the zeros in there. 10 to the minus 9 is a much easier way to do it. We're trying to find nanometers. We have meters, so meters are going to have to go on the bottom, and nanometers are going to have to go on the top. Remember, the way we read this table, the way we interpret this table, this number is always being applied to the base unit, and meters are a base unit. So it is going to be 10 to the minus 9 meters for every 1 nanometer. All right, and then crossing off units, meters cancels off meters. That leaves nanometers as my answer, and that is going to equal to 3.725 times 10 to the 11 nanometers. All right, nice big number as we'd expect. There's a lot of nanometers in a meter, and then there's a lot of nanometers in 372.5 meters. Okay, again, I'm just going to recap here now. This table has these different prefixes. I should make one more point here, and that is, as far as we're concerned in this class, you need to know from tera down to femto. Okay, you need to commit this to memory. You do not need to know peta, exa, or atto, but you need to know all the ones in between. So you notice these all, except for the centi one, these all jump by 10 to the minus by 3s. Okay, so it's milli, micro, nano. So you're going to need to know the name, you're going to need to know the symbol, and you're also going to need to know this multiplier. So just become familiar with them. There's a couple of them larger than 1, kilo, mega, giga, and tera, and there's a whole bunch of them smaller than 1. All right, the other important thing I want you to take away from this video is this is the most common mistake. This conversion factor. When you do the conversion factor, I already said this at the top, I'm going to say it at the end just to remind you, it's a super common mistake that students make. This number here is always applied to the base unit. So nano, 10 to the minus 9 meters for every 1 nanometer. Zim dollars, 1 kilo zim dollar for every 1,000 zim dollars. 1 mega zim dollar for every 10 to the 6th zim dollars. So remember, whatever this number is here, 10 to the 6th, that gets applied to the base unit, and the conversion then goes on the other side, 1 mega zim dollar for every 10 to the 6th zim dollars. All right, next video is going to deal with significant figures.